Hey everyone, it's that math magician. On this video, we're going to take a look at another example for how we can use our formula called the Law of Cosines. Now in the previous introduction video, we looked at an example where we solved for a missing side. On this video, we're going to see how we can use that formula to help us solve for a missing angle in a non-right triangle. So let's dive right into our example problem. And that is, we have a triangle here where I actually know all three sides of this non-right triangle. This is a scalene triangle. I see that my long side here is 51 inches. We have this side over here that's 37 inches. Finally, this side down here is 19 inches. And I'm interested in this angle here. I'm calling it theta because I do not know the value of this angle. And we want to see, can we use our formula for the law of cosines to help us solve for this problem? And I think we'll be able to. Now, before we jump into this, we have to first identify what sides we have. I know that I need one of those to be represented as C, and the other two will be represented as A and B. Now, just a quick reminder, the C term, the C side, that is always the side that's opposite of the angle you're focusing on. Remember, for law of cosines, you're looking at a single angle in the non-right triangle. So whatever angle you're focusing on, in this case for us it's theta, C is the side opposite of our angle. So I can see there that 51 inches is going to be representing my C side. So in terms of my formula here, I know that for C squared, that is going to be changed to a 51. Now, the A and the B, those are the two remaining sides that are actually going to form the angle. The A and the B, they form the angle that we're looking at. And we see here that 37 inches and 19 inches, those two sides are the sides that are forming angle theta. Now, it doesn't matter which one you label as A and B. So I'm going to go ahead and label 37 inches as A, and I'm going to label 19 inches as my B side. Again, you could swap those. It doesn't truly matter. What's very important, though, is that the C side is by itself. So now that I know that A is 37 inches, I'm going to put that into the equation. I'm going to have A squared, so 37 squared, plus B squared, which is 19, so we'll have 19 squared, minus 2 times my A times my B. Well, my A here is 37, my B is 19, all multiplying cosine of my angle. In this case, the angle we're looking at, theta, is unknown. So I'm going to go ahead and put in theta as the unknown angle for this equation. You see there, I have a single equation. I have numbers everywhere except for the one unknown that I don't know. This is what I want to find. I want theta by itself. Now we just shift over and look at our equation, and we need to do some algebra to get theta by itself. We want to isolate theta so we know what this angle equals. Now, this is not like the introduction video that was before this one. We cannot just enter this all into our calculator. It's going to require some work for us so that we can get theta by itself. So the first thing I'm going to do is I'm going to break out my free calculator here from Desmos.com, and I'm going to start using it to help me simplify this equation. I have 51 squared here on the left side all by itself. So I'm going to type in 51 squared, and I see if I can type it in. 51 squared ends up equaling 2,601. So I'm going to change that over here to be 2,601. That equals, 37 squared. So I'm going to go ahead and type that in now. 37 squared. That is 1369, so I'll put that in. Plus 19 squared. I cannot enter in these numbers correctly today. This is great. 19 squared. That makes 361. Minus, remember, we need to do 2 times 37 times 19. So I'm going to punch that into the calculator. 2 times 37 times 19. We see that this value here in front of the cosine ends up equaling 1406. So I have 1406 times cosine of my angle theta. So again, all I've done so far is simplified 51 squared, 37 squared, 19 squared, and then I multiplied 2 times 37 times 19. We have 1406. All right, let's start combining some like terms. It looks like I can combine 1369 plus 361. So I'll use my calculator. 1369 plus 361, whoops, not minus, plus 361. That ends up equaling 1730. We know we're still subtracting 1406 times cosine of theta. And this all still equals our 51 squared, which is 2601. Now, let me tell you the biggest mistake that I see students make at this point. They see 1730 minus 1406, and they want to combine those, and they want to subtract those two terms. That is incorrect. We cannot combine these because this is not just 1406. It also has a cosine attached to it. And the best way I can explain that for you is you would never combine these two terms together, right? You would never combine like terms here because these are not like terms, because this number has an x variable. Same thing up here. We have a cosine of theta. That's our variable. So we cannot just add those two terms together. Subtract those two terms. So what we need to do then is we need to subtract 1730 over to the other side. We're going to do that so the 1730s there zero out. And on the left side, I'm left with 2601 minus 1730. And that equals 871 on the left side. And that equals negative 1406 times cosine of my angle. We are almost there. I almost have cosine by itself. The next step that I have to do is I want to get rid of the negative 1406. That is multiplying our cosine. So I will divide both sides by negative 1406. By doing that, those become a giant 1. They cancel out. So on the left side here, I'm left with just cosine of my angle theta, and it equals the fraction 871 over negative 1406. The very last step we have to do as I scroll up is I want theta by itself. To get theta by itself, I will need to take the inverse cosine on both sides. I do that and I end up with theta equaling the inverse cosine of our fraction 871 over negative 1406. That is the step that we want to enter into our calculator, and we will finally figure out what our missing angle is. So again, let's jump over to desmos.com and let's enter that into our calculator. Remember, if you're using this calculator, inverse cosine is underneath that function button. You'll need to click on the inverse cosine, jump back to the main panel, and I'm going to type in my fraction there. 871 divided by negative 1406. And we see that that missing angle for theta is 128.279 degrees. Go ahead and write that out. 128.279 degrees. That is our missing angle, and we found it in a non-right triangle by using the law of cosines. Okay? Is this a little more work than the previous video where we solved the side? Yeah, definitely. We weren't just able to enter in that whole string into the calculator, press enter and get our side. We actually had to do some algebra, but all it really was combining like terms, moving those numbers to the opposite side. We wanted to isolate our theta variable. And once we got there with inverse cosine, our calculator was able to tell us that our missing angle was 128.279 degrees. Okay. All right, guys, it's that math magician, and I'll see you on the next video.